What's going on, everybody? John here, UJAM Custom Design, and today we are going to be talking about drawings, specifically with regard to sheet metal parts. Now, our last video focused on how to create a DXF, which is what is going to tell the shop where to cut. All right, so if you're creating a sheet metal part, that DXF is going to tell the head of the laser or water jet or plasma where to travel so that it can cut out that object. But what it doesn't tell them is how thick the object is, what type of material it is, and if there's any bends, where are they going to make those bends and at what radius. So the drawing is what's going to tell them those three key pieces of information. And today we're going to show you exactly how to do it in Fusion 360. But wait, before we get started with that, I just want to remind you, if you find this video helpful or if you find this content in general helpful, please make sure, give me the thumbs up on the video, give me a like, and remember to subscribe so that you'll be notified anytime we've got new videos coming out. And if you like to hang out, you'll find me on Twitch, twitch.tv/Jilkins, right there. I just like to hang out and chat most of the time, and you'll probably catch me on there designing something. So if you just want to hang out, feel free to come by. Now that that's out of the way, let's get started. Right, let's jump right into it. So we have our former model up here that we used in our DXF creation video. So if you want to learn how to create a DXF, make sure that you visit that link in the description below. But today we're going to be focusing on how to create a drawing for this part. And step number one is you need to create a flat pattern. See said video. After that flat pattern is created, then we need to go to File, go down to New Drawing, say From Design, and we are going to, under the representation within this drawing menu, we are going to select Flat Pattern. We're going to create a new drawing from a scratch template. There are, some ASME and ISO standard templates that are really good. I just use ASME in inches, and then I always change my sheet size to 8.5 by 11 or 11 by 8.5. That's just because it's the only size of paper that I have access to here, and I know that it's scalable, but I just like to do it this way. So I'm going to hit OK, and that is going to give me my drawing, and you'll see that it already has populated a base view for me. Now we can change the orientation of that view if we want to the right or the left or the top. None of those give us a whole lot of information. So the thing that we want to focus on here is we need to give the people who are going to be cutting and forming this object, one, we need to give them some overall dimensions for the part so that when they go to cut it, they know that they're not cutting something that's wrong. So we need to give them the face down view of that. And for that, that is our front view. This is what we want to show them and actually put some overall dimensions on it. The other thing that we want to show them is going to be a form dimension or a bend dimension. So where is that bend and what radius does it need to be bent at? So we obviously need this view to do that as well. So I am going to change the scale of this to 1:8 just to give it a little bit more space occupied on the screen. And I am going to go ahead and click to place it and hit OK. Now it's going to give me my nice line art drawing here. And you'll see that it gave us, with those settings we had, a bend line right here. One of the other things that I like to do when I am giving a drawing to a shop is I like to give them something that shows them the final product. And I usually like to put that up in the upper right hand corner so that they can see what it's supposed to look like when they're done. So in order to do that in this drawing file, we need to create a new base view based on our folded model, not our flat model. So we need to go to base view up in the top left, It's going to pop us up a new drawing view. You'll see that it's giving us what is referred to as the front orientation based on our design. That's not going to tell us much, so we need to change the orientation to an isometric view. I'm going to go ahead and select Southwest Isometric. Now, it's not always the case that it is going to give you something that looks good, all right? So what I mean by that is you'll see that this Southwest Isometric view is not that great of a representation. Neither is Southeast. They just look weird, right? Northeast looks weird. This is probably the best one right here, in my opinion. Northwest, also not that good. I'm gonna go ahead and say Northeast Isometric. We will be covering in another video how to create a new drawing view so that you can get something that actually looks decent here. But for today's purposes, I think this will be just fine. The scale, again, you can change this to whatever you want. If you want it to be bigger, I usually like to make it a little bit smaller, so 1:20 or maybe 1:16 looks good. And I'm going to go ahead and click, and that's going to place it there, and I'm going to hit OK. And now that at least gives some kind of reference to the shop of, okay, we've got a bend right here, and this is what the final part is supposed to look like. Okay, now we need to place some overall dimensions for this part. And for that, I'm going to go to dimensions up here. I'm just going to click my linear dimension, and I'm going to select these two edges, and I'm going to select these two right here. So this is just a couple of overall dimensions telling the fabrication shop that this part is roughly 9 inches by 43 3/4 inches. So if the scaling of our DXF is off, which it should not be if you follow the last video, but if it is by any chance, this tells them, all right, something's wrong, and we need to ask whoever designed it to redo it for us. So now we've got our overall dimensions. The next thing we need to place is going to be a bend dimension. And in order to do that, I just like to go to the bend line and reference from one side right there. So you can see that this is about 4.5 inches, or roughly halfway on this part. Let's give ourselves a little bit of room here and a little bit of room here. All right, now we've got the 3 primary dimensions that we need. They don't need to know how big all those little circles are, because our DXF is going to tell the laser exactly the size of all that. Now, the last little piece that I like to put on here is I like to actually reference this bend so that they know exactly what radius and which bend we're talking about, especially on drawings that have multiple bends. So in order to do that, we are going to go to, is it symbols? No, tables. Bend identifier under the tables menu. And we're going to click that. And we're just going to select our bend center line. It's even telling us in the note right there, select bend center line. I'm going to click on that, and it gives us a little 1 right here. Now, this is important, especially on drawings with multiple bends, because it's going to label all of those, and then we're going to put in a table that shows what those bends are. Now, to do that, we're going to go to Tables, and we are going to say Table. And we selected our drawing view. That was a little weird, but anyways, clicked on our parent view, just in case you missed that. It was a little quick. And then we're going to click to set our table. So it's automatically creating this bend table for us, which, as you can see, with multiple bends is a really, really nice little feature. So what this is doing is it's telling the shop, here's the bend ID, number 1 right here. The direction of the bend is down. So this is important because you're going to have some bends, if you have a flat view, some bends are going to be down and some are going to be up. And it tells them what angle to bend it at. So if it's not a perfect 90, if it's 30 degrees or 45 degrees, it's going to tell them exactly what that angle is, and then the radius that it should be bent at, which in this case is the same as the thickness of the material. It's about 3/16, 1875. All right, so the last little piece is we need to tell, I'm going to go ahead and move this table a little bit so it's out of our way. The last pieces we need to tell them are, what do you need to do with this part? How thick is the part? And what kind of material is it? And in order to do that, I'm just going to place some text, specify the first corner, drag out my little text box, and just type some notes. Notes. Number 1, cut and form. So I'm telling the shop that they need to cut it first, and then they need to form it. And I'm expecting a complete cut and form part. Number 2, I'm going to tell them the material type, which for this is going to be A36 hot roll steel. And then for number 3, thickness is going to be 3/16. And that's all we need to tell them. Now this drawing, and you can put in your other stuff here, drawing number, we've got the scale. The scale was automatically populated, by the way, based on our parent view placement. But you can populate a drawing number, you can populate your name, date, title, project, all that kind of stuff if you want to. But this drawing now contains all of the information for this particular sheet metal part that a shop is going to need in order to create it for me. And you can create a PDF output if you want, but otherwise, this thing is pretty much complete. And with that, just another quick reminder, if you like this video or if this content helped you at all, just remember to give it a thumbs up and hit that subscribe button so that you can be notified whenever we've got new content coming out. And again, if you want to hang out and just chat, if you want to ask me questions, or, if you want to play a game or something like that, catch me on Twitch, twitch.tv/Jilkins. I'll put it right up there so you know how to spell it. And until next time, happy designing.